Hello everyone, today we are going to present about temperature and heat.
So firstly, why are we interested in this topic? Our group finds interest in temperature and heat due to its relevance in everyday life, including cooking, weather patterns, clothing choices, heat conduction in materials, volume changes in gases, and environmental issues like global warming and climate change. Additionally, temperature and heat play a crucial role in dentistry, such as instrument sterilizations, material shaping or customization, and cooling techniques to prevent thermal damage and patient's discomfort. So, how is this topic relevant to our field? In dentistry, heat and temperature are vital elements governing procedures, materials, and equipment. They play pivotal roles in curing materials, sterilizations, radiography, ensuring patient comfort, and maintaining equipment functionality. Dentistry carefully manages thermal sensitivity and equipment heat to ensure safe treatment. Material selections is guided by thermal properties to enhance durability. A deep comprehension of heat is essential for delivering top-notch dental care.
The first one is heat. Describe the transfer of thermal energy between molecules within system and measure in joules. Heat measures how energy moves or flows. An object can gain heat or lose heat, but it cannot have heat. Heat is a measure of change and never a property possessed by an object system, so therefore it is classified as a process of variable. The second one is temperature. Describe the average kinetic energy of molecules within a material or system is measured in an Celsius, Kelvin, Fahrenheit, or Fahrenheit. It is measurable physics property of an object, also known as a state variable. Other measurable physical properties include velocity, mass, and density, to name a few. So now let's move on to the relationship between heat and temperature. Temperature and heat are linked, but it's separate concepts. Measured in degrees Celsius or Kelvin and joules, respectively. Temperature reflects particle motion, while heat denotes energy transfer. Temperature is a constant regardless of mass, aiding in substance identification, while heat is flows from warmer to cooler system until equilibrium is attained.
Okay, let's move to another topic. It's how to calculate. The first one is heat to change the temperature. Q is amount of energy required to change temperature of matter based on mass, specific heat capacity, and temperature change. This is given by Q equal mc delta T. The second one is heat to change a state of matter. Q is the amount of energy required to change the state of matter based on mass and latent heat. This is given by Q equal mL. And the last one is different temperatures. When different parts of an isolated system are at a different temperature, heat will flow from the part at higher temperature to the part at lower temperature until all parts of the system reach the same temperature. They call thermal equilibrium. This result is conserving of energy. Q loss equal Q gain. For the example, this question asks about determine the specific heat of metal. So the first one is let C be the specific heat of metal. And next one is heat gained by the metal. Q equal mc delta T. M equals 60, C that we don't know, and delta T is equal to 80. The next one is heat released by the stream. Q equal mL. M is 0.5 and L is 540. So The principle of mixture, heat given is equal to heat taken, that is 0.5 times 540 equal to 60 times C times 80, so C is 0.056.
And for the next topic, we're going to talk about how temperature and heat involve in daily life. So the first one is conduction. It's like when heat moves through the stationary metal via direct contact. Despite the metal appearing still, atoms and molecules are in motion. For instance, heat travels from a stove, electric burner to the bottom of pan through the conduction. And the second one is convection. Is the heat transferred by microwave movements of the fluids. This type of transfer takes place in a forced air furnace and inverter system. And the last one is heat transfer by radiation. So radiation occurs when virus of electromagnetic radiation like microwave, infrared, or visible light are emitted or absorbed. Examples include the sun heating the earth and the thermal radiation emitted by the human body. And for the example, like air heat, like gravity furnace expand and raises, forming a convective loop that transfers energy to other parts of the room. As the air is cold at the ceiling and outside wall, its contract eventually becoming denser than room air and sinking to the floor. A properly designed heating system using natural convention like this one, it can be quite efficient in uniformly heating a home.
In conclusion, temperature and heat are crucial concepts in understanding everyday processes and specialized fields like dentistry. They govern heat transfer mechanism and also materials behaviors, impacting everything from cooking to sterilization procedure in dental clinic. By grasping their principle, we can enhance efficiency and safety across various applications, making them indispensable in both scientific and also practical contexts.